Welcome. Last time we worked on adding and subtracting fractions with renaming. Today we're going to add and subtract mixed numbers. Before we begin, let's do a quick fact review. How are you doing with your fact memorization? I hope you'll treat each day as a day to improve your speed and accuracy. Once mastered, those facts will be a strong foundation for math success. Let's use mental math to solve another letter in the secret word for this chapter. Today's equation is 2 times 4 times 5 divided by 4 equals. Write the letter in the blank for day 134. All right, time to add. We are adding mixed numbers. What's a mixed number? A mixed number is a whole number and a fraction. So when adding, we always start with the smallest unit or the place with the least value. So we're going to start with the fraction. 1/8 plus 5/8 is 6/8. And then we add the whole number. 2 plus 1 is 3. 3 and 6/8. Add the fraction, add the whole number. Easy peasy. Now you try some. What is 1 1/4 plus 3 2/4? Add the fraction. That's 3/4. Add the whole number. 1 plus 3 is 4. 4 3/4. What is 4 3/7 plus 1/7? Yes, it's 4 4/7. Now, sometimes when you add a mixed number, you might need to do some renaming. I know you can do this because we've already worked on the skills that you need. What should we add first? The fraction. 4/6 plus 4/6 equals 8/6. Now add the whole numbers. There's 1 whole in the first number and 0 in the second. 1 plus 0 is 1. Now what do you know about the fraction in the sum? Yes, 8/6 is improper. Any fraction that has a numerator that is the same or greater than the denominator is an improper fraction, and we need to rename that. Grab your fraction circles. You need 8/6. How many of these pieces do you need to make a whole circle? These are sixths, right? It takes 6/6 to make a whole, and then how many sixths remain? Yes, 2. Let's show that in the equation. We can rename 8/6 as 1 whole and 2/6. How many wholes did we have in the original problem? We had 1. We renamed 8/6 as 1 and 2/6. So how many wholes are in the sum when the 8/6 was renamed? 2. And how many fractional parts are in the sum? 2/6. I'd like you to try one with me. You're going to need a piece of scrap paper to write down this equation. Let's add 1 2/4 plus 1 3/4. Write that on your paper for me. All right, where do we begin? Add the fractions. 2/4 plus 3/4 equals 5/4. Now add the whole numbers. 1 plus 1 equals 2. Great. Now all we need to do is take care of that improper fraction. We don't want to leave it like that. We have 5/4. So how many fourths do we need to make a whole? It takes 4/4 to make a whole. And how many fourths do we have left over? 1. We had 2 wholes in the original answer. We renamed the improper fraction as 1 1/4. So now we have 3 wholes and 1/4. 3 1/4. I'd like you to try one on your own. Remember to think of the fractional name for 1 when renaming the improper fraction as a mixed number. Now this one's written horizontally, but just do it the same way. Add the fractions and then the whole numbers. Pause and solve this equation. "3/8 plus 5/8 equals 8/8. 2 plus 1 equals 3. The improper fraction 8/8 is equal to a whole, so the answer is 4. Renaming an improper fraction just requires you to think about how many of those fractional parts make a whole. Now let's try putting that skill to use by solving a word problem that has mixed numbers. Sandra needs to bake 2 cakes for her grandparents' 50th wedding anniversary celebration. Her cake recipe calls for 2 3/4 cups of flour for 1 cake. If she doubles the recipe to make enough batter for both cakes, how much flour will Sandra need? Do you like to bake? I do. In fact, baking is where most of my fraction knowledge comes in handy. Sandra needs to figure out how much flour to use. What equation can we use to figure that out? Each cake needs 2 3/4 cups of flour. So 2 3/4 plus 2 3/4. Let's first add those fractions. What is 3/4 plus 3/4? Yes, that's 6/4. Now add the whole numbers. 2 plus 2 is 4. Now what do? We got to take care of that improper fraction by renaming it as a mixed number. We have 6/4. How many fourths make a whole? 4. So how many fractional parts will we have left? 2/4. So 4 cups plus another 1 2/4 equals 5 2/4 cups. So Sandra needs 5 2/4 cups of flour. If you think about it, 2/4 is the same as 1/2. They're equivalent, aren't they? So we could have said Sandra needs 5 1/2 cups of flour. Great job with adding mixed numbers. Now let's dive into the work text and practice. We have a few to solve horizontally and a few to solve vertically. Add, rename if needed. Watch out for that. All right, let's add our fractions first. 4/5 plus 3/5. Yes, you know that is 7/5. And then add your whole numbers. 3 plus 4 is 7. Now, that's an improper fraction, so we need to rename, don't we? How many fifths make a whole? 5/5. So that's going to be another whole plus what? 2/5 more. So we're going to say that's equal to 8 2/5. 1/2 plus 1/2. Good. 2/2. And 2 plus 4 is 6. Do we need to rename that one? We sure do, because we can't leave it as 2/2. 2/2 is a whole, isn't it? Because your numerator and your denominator are the same number. So that's just going to equal 7. 2/3 plus 2/3? 4/3. And then what's 6 plus 6? Yes, that's 12. We're going to rename now. What are you going to write down? 4/3 is equal to a whole plus another third. So that's 1 1/3 plus the 12 gives us 13 1/3. All right, last one, 3/9 plus 4/9. Nice, and then 8 plus 1 is, that was an easy one, wasn't it? 9 and 7/9. All right, now we can add them vertically. What is 4/6 plus 4/6? Good, 8, 6, then add 4 plus 1. That gives you 5. Gonna do a little renaming, and what should you have? Were you thinking 6 and 2/6? Add here 1/7 plus 2/7, and then 3 plus 4 is 7. 7 and 3/7. That was an easy one. All right, half plus 1/2. That gives us 2 halves. You can either think in your brain 11 plus 3, or you can add the columns. 1 plus 3 is 4. 1 plus nothing is 1. Either way is the same. But we do need to rename that fraction because it's an improper, so that would give us 15 altogether. 4 plus 5 gives us 9/6. 7 plus 2 is 9. And what do we have? We're going to get another whole, aren't we, out of this one? Plus we're going to have 3/6 more, so we're going to have 10 and 3/6 all together. Now that we've added, let's try subtracting mixed numbers. Just like with adding, we start in the place of least value. So let's begin with the fraction. 5/6 minus 3/6 is 2/6. Then subtract your whole numbers. 3 minus 1 is 2. Do you think you can do that? I think you can. You solved this next one on your scrap paper. 4 and 6/7 minus 3 and 4/7. Write that down quickly. Are you ready? All right, first subtract the fractional part, then subtract the whole number. What did you get? Did you get 1 and 2/7? Just like regular subtractions, sometimes you're going to need to rename when subtracting mixed numbers. 1/10 minus 8/10. Do we have enough tenths to subtract? No, we need to rename one whole as tenths. How many tenths are equal to one whole? 10 tenths. How do you figure out how many tenths you have altogether? You add what is 10 tenths plus 1/10? 11 tenths. So we're going to rename that as 11 tenths. Now we have enough tenths to subtract. What is 11 tenths minus 8 tenths? 3 tenths. Now subtract the whole numbers. 1 minus 1 is 0. And we don't need to write that 0 in the answer. Now think with me. Besides fractions, how else can you represent parts of a whole? You could use decimals. How are these subtraction problems similar? Well, they're the same because the decimals represent the same value as the fractions. 2 and 1/10 minus 1 and 8/10. When we subtract the decimal problem, we get 3/10, the same value as the subtraction problem using mixed numbers. You know who likes fractions? Lizzie. I think it's because she can always find a way to demonstrate them using food. Let's see what snaptastic tips she has for us with mixed numbers.
So way back, we talked about changing improper fractions into mixed numbers. Well, today we're going to talk about it again, except in reverse. We're subtracting mixed numbers. As you know, pizza is usually my go-to food for fractions, but I'm changing things up today. Let me introduce chocolate bars. This is going to be sweet. I have 1 chocolate bar and 3 pieces. Each chocolate bar is made up of 12 pieces. So you can think of my chocolate as the mixed number 1 3/12. Now we're going to subtract 5/12. That's 5 pieces. That's a bit hard to do. I only have 3 pieces. It's time to snap apart my chocolate bar. Now I have 12 more pieces, or you could say 12/12. When I add them to the 3/12 I already have, I get 15/12. Now, let's try that subtraction problem again. 15/12 minus 5/12 is 10/12. That was so much easier after we changed the mixed number to an improper fraction. But what if you have a subtraction problem with 2 mixed numbers? Something like 6 2/8 minus 2 4/8. How do you even begin? Remember this snaptastic tip. Subtract the fractions first. If you don't have enough parts of the whole in the first mixed number, you need to rename one whole number as its fractional parts. And, of course, add it to the fraction. Now you can subtract. Next, subtract the whole numbers. And finally, write the answer. It's kind of like solving 2 subtraction problems and then putting the answers together. Renaming is tons of fun. I could rename these Cocoa Bites or maybe Sweet Confection Bricks. This could be a cheesy dough disc. Or I could stick to renaming mixed numbers and fractions. I can do those in a...
I'd like you to solve this next one with me. Write it on a piece of scrap paper and work with me as we rename to subtract. 5 3/6 minus 2 5/6. Where do we begin? Yep, begin with the fractions. We do not have enough 6 to subtract, so we need to rename one of the wholes as 6. How many 6 are in a whole? 6, right? 6. Now, how many 6 will we have? Well, we'll have those 6 plus the 3 and that gives us 9 6. Now we can subtract. 9 6 minus 5 6 is 4 6. And then 4 minus 2 is 2. 2 4 6. How would you like to be independent? You can do it. Pause and solve this subtraction equation. You needed to rename to get enough ninths. Then you had 10 ninths minus 6 ninths, so you should have had 4 ninths. All right, let's get back into that work text and do the subtraction equations. We're going to subtract, rename if needed. Now, the renaming is already done here for us, isn't it? We could not subtract 1 6 minus 5 6, so we took one of the wholes, so we only have 3, and we renamed that as 6 6, plus the 1 6 that was there gave us 7 6 all together. Now we can subtract. 7 6 minus 5 6 is 2 6, and then 3 minus 1 is 2. All right, let's try this one. This up here tells me, I must need to rename, because I cannot subtract 1/3 minus 2/3. So take one of your wholes, cross off your 7. Okay, now we're only going to have 6, and we're going to rename that whole as thirds. How many thirds does it take to make a whole? 3/3. Plus we already had 1/3. So how many thirds are we going to have all together now? 3/3 and 1/3 gives us 4/3. Now we can subtract. 4/3 minus 2/3. And then 6 minus 2 is 4. Nice job. Now this one's a little tricky, isn't it? We don't even have a fraction. We need to subtract 5/8. So what we need to do is take one of your wholes. All right, so we're only going to have 5, and we're going to rename it as eighths. So we're going to have 8/8. Now you can subtract. What is 8/8 minus 5/8? You know that's 3/8. And then 5 minus 4 is 1. That one was a little bit trickier. All right, let's rename. Take one of your wholes. It leaves you with 8. And we'll rename that as fifths. So we have 5/5 because that makes a whole. Plus the 2/5 that are there gives you how many fifths? Nice, 7. So we're going to write a 7 right there. Now we can subtract. 7/5 minus 3/5 is 4/5. And then 8 minus 4 is 4. Now these are written this way. Don't let that confuse you. We're still going to do the same thing. 7/8 minus 2/8 is 5/8. And then 8 minus 2, good, 6 and 5/8. 1/4 minus 2/4 we need to rename, don't we? Because that's not enough fourths. So cross off your whole and rename that as fourths. That's going to be 4/4. Plus you already had the 1/4. So how many fourths do you have? Yeah, you have 5/4. Now we can subtract easily. 5/4 minus 2/4. And then subtract your 3 minus 1. All right, last one. See if you can beat me. Let's do it. I'm going to rename. I'm going to call that sixths. Got to add that other 6 in there, right? Did you have 7/6 so that you can subtract? 7/6 minus 2/6. Good. And then just subtract 2 minus 1. Nice job. All right. That was a good day's work. We've had lots of practice adding and subtracting mixed numbers. Now let's take a look at your assignment for today. First, you're going to solve. Make sure you rename if needed. Adding, subtracting. You can do that. Look back on the other side if you get confused. That'll help you. We've got a couple of word problems to solve and label. Make sure that you do some renaming in here too if you need to, all right? Complete the fraction to make the statement true. We have worked on these. Halves. What's equivalent to 1/2 if you're talking about sixths or tenths or fourths? You can do those well. And then down here, we're writing the fractions in order, but we're going to always be thinking about half. For example, 4/4. That is a whole, right? So you know that's more than a half. So you'll fill these in. Always compare them to a half. You can do it. We've talked a little bit about equivalent fractions, and we've already learned how to make fractions equivalent to 1/2. Next time, we will find equivalent fractions by repartitioning shapes, using number lines, and using multiplication. It's going to be fun.